Well, what's going on, everybody? Thanks for stopping by. Thanks for stopping back. In this video, based off the title of the video, obviously we're going to be talking about HA, high availability. This is going to be with active standby, and we're going to take a look at the different variations of it. Now, there are some back-end things that we need to understand about what is happening with the ASA and stuff like that. So we're going to be playing with ASA 3 and ASA 4. As a matter of fact, let me go ahead and move me over to here, so that I'm out of the way. So normally I look this way, but it's just gonna have to work. And ignore the dog and the barking in the backyard. So what we're gonna be taking a look at is you might notice a little bit of a different way that I've put stuff together in this topology than I did in some of the previous topologies. And that's because as I'm going through different sections, and the way that I had stuff cabled up just isn't going to work. It's not going to work for what I needed to do and stuff like that. So I needed to basically power stuff down and make some modifications. And I'm figuring all this stuff out, documenting what I'm doing, and I can come back later on and show you guys in the video so that it's, you're not having to sit there and wait for me to figure it out. Right? So basically what we have is ASA 3 and ASA 4 were originally deployed as a firewall 1, firewall 2, if you will, and we're simulating a customer that needed to have an HA pair. And the customer basically, this is all 100% hypothetical here and not real. What we ended up doing was, and what we're going to be doing is going to be setting up first what they refer to as stateless high availability. Now there's stateless and there's stateful. And as we go through, you're going to see some of the things that need to be understood about how this all works behind the scenes. Now I'm not going to be going through all the nitty-gritty details for how all this stuff comes into play. But what I will be explaining is why we need to have the interfaces set up the way that we do. And the primary reason for that is when we are looking at, for instance, and I know I'm looking to I'm looking away when I'm actually looking at the topology. One second here. Wrong screen. There we go. When we're looking at this, the gig 02 and the gig 02 on both firewalls needs to be the same. Gig 1 and gig 1 needs to be the same. Gig 0 and gig 0 need to be the same. The reason why they need to be the same is because when we go to configure the failover and all that type of stuff, the inside interface on one firewall needs to be the same as another firewall, nomenclature wise. Gig 02 to gig 02, because when you're swapping the configs, you can't go from gig 02 to gig 03. It's not going to work out that way. So what will end up happening is we'll configure stateless failover on ASAV3 and ASAV4 and go through the process of getting all that stuff squared away and ready to roll as we're going along. And as we get that type of stuff ready to go, we'll be able to take that further and make sure that we understand all the details that go into that. Now, beyond that, we will be near the end of the video going over what they call stateful failover, where connection information between the firewalls is shared and all that type of stuff. In stateless firewall, it just is a secondary device in case of a primary failure. That's it. So if we open up a connection from test 15 to R2 to simulate connectivity end to end, what you'll end up finding is if we do a failover sequence where we actually initiate the failover through the command line and not have an actual device failure, then we'll see how ASAV3 passes to ASAV4. But what's actually interesting about it is they both appear as they are ASAV3 and not ASAV4. ASAV4 is just the name of the node in Eve, but actually doesn't have anything to do with the nomenclature. So with that being said, once we take that logic into consideration, a lot of what we're going to have to do is the basic config. So I'm actually going to go through and wipe the config clean on ASAV3 and ASAV4. We're going to reconfigure this. So this is going to be from a ground up configuration, and you and I will go through as if this was a brand new box. Now we're going to be doing some basic stuff here. We're going to go through, we're going to configure the interfaces, we're going to configure some basic NAT, so it's just some object NAT like we've already covered in some previous videos, and then go through the failover process. It's actually really, really easy to do and get working. That's what we're going to do, and go from there. So on ASA v3, now this is currently a working solution, so I'm breaking it on purpose for the purposes of this video. And I test things out, document what I found, any caveats that I ran into, and go from there. That's why when I bring up the interfaces need to be the same, there's a reason for that. So, and we'll change I'll show you guys how to change the prompt as well as we're going through this so that you can see which particular ASA you're on. So I'm going to go in here and I'm literally going to type in clear configure all on that router, or I'm sorry, on that ASA, and clear configure all on this guy. So basically it's going to bring them in as brand new firewalls. You and I are going to go through all the steps that we need to in order to get these guys up and running. And there's not a lot that we have to do, but the things that we have to do are pretty straightforward and just need to be followed in a set order. So what I'm going to do is I'm going to come in here and type in hostname is going to be ASA3, and I'm going to go in and type in interface gig0/0 is IP address of 202.1.10.10/24. No shut it. Name if is outside. And then I'm going to go type in interface gig02. IP address is 192.168.15.1/24 with a standby of 192.168.15.2. Okay. Now I'm also going to type in on this guy that it's the name if is inside and no shut the port. So show interface IP brief. So those interfaces are now configured and operational. Now what we have to go do is I'm going to go ahead and I'm going to ping 202.1.10.1, and I can ping R2, which is a really good first step because I know that I have reachability to that extent. Now, as far as I've taken it, that's as far as I really need to go, base configuration wise. I will go in here and make a couple of other changes. So as we're talking about getting this stuff squared away, the next thing we have to do is configure the failover. So the very first thing I'm going to do here is I'm going to type in failover unit or LAN unit primary, because ASA v3 is going to be the first guy to go. And then I had to determine the actual failover interface. If there's a failover, which way do we exit? Which way does the traffic exit for failover? So if traffic comes in on one interface, does it leave out another? How do they sync between them? Sync stuff like that. So we're going to go ahead and type in failover. We'll type in LAN interface. LAN interface. In this case here, it's going to be the name of the interface is going to be failover. Something very simple. And then interface, or I'm sorry, gigabit 0/1. And I'm going to go ahead and then type in the failover interface IP address for FO is going to be 192.168.255.1/30. Yeah, /30. And the secondary is going to, or the standby is going to be 192.168.255.2. Hit the interface, or hit the enter key. And last but certainly not least is going to be the failover. Okay. Now, normally you would want to wait until this is a little further along. Let's do a show interface IP brief, and we have to go and type an interface gig0/1 is no shut. Bring that guy up. Now we're going to do the exact same thing on ASA4, and we're going to come in here and type in the failover LAN unit is secondary, and that the failover LAN interface for failover is, in this case here, is gig0/1. and that the failover interface IP for failover is 192.168.255.1/30. And that's it. And then once we have that configured, we have to come in here and type in failover. Now what's going to end up happening is they're both going to start talking to each other. No active mate detected. And then we're going to do a show interface IP brief. We have to come over here and type in interface gig0/1, no shut. Interface gig0/0, no shut. And then what will end up happening is there will be a configuration update sent from ASA 3 to ASA 4. Or if we look at ASA 4 and we hit the enter key, we're going to see ASA 3. And the reason why we're seeing what we're seeing is because the configuration of ASA 3 got copied to ASA 4. So it's a little hard to tell. If you're looking at this, you're like, well, wait a minute, what's going on here? There's a simple way to fix this. On this guy, we're going to type in prompt. We're going to say priority, state, and host name. And then we come over here, and we hit the enter key, and it does the same thing. So we are on ASA 3 is the primary active, and ASA 4 is the secondary standby. So it's ASA 3 is actually two devices now. It was ASA 1 or ASA 4. ASA 4 is a secondary unit, therefore he is just backup in case something happens to ASA 3. ASA 4 is used for failover. However, this is not a stateful configuration, which means when I go on ASA, if I go to ASA 3 and I come in here, I type in object network is going to be LAN, and I type in subnet is 192.168.15.0/24. I type in NAT from the inside to the outside dynamic interface. So I can set up NAT now. If I go to, and I go out here and I type in route outside 00 202.1.10.1, I do show route. I'm going to have a default route outbound. Now what I have to go do is on test 15 and show run policy map. I have to go in here and inspect ICMP. ICMP. And then from test 15, I should be able to ping 202.1.10.1. If I could spell it correctly, that'd be awesome. I can ping 202.1.10.1. Now if I open up a telnet session to 202.1.10.1, it pops open. I type in Cisco, enable Cisco, and I then go to, that's not what I wanted to do. Pardon me, folks. The next thing that I need to go in here and do is look at ASA 3 and do a show connection long. And you're going to see an active connection from test 15 to R2. So that's an active connection that's going on right now. It's happening. Everybody's having a good day so far, right? The drawback to this is it's not a stateful configuration. So on here, if I come in here and I do a show failover, here's a couple things you're going to see. At the top here, we have the failover is on. This is the unit, the primary unit. The LAN interface failover is gig0/1, and that we have a maximum of 61 interfaces that can be monitored. Currently, the only interface that's monitored is the gig0/2 interface. And then we can come through and see that we see the other serial number of our mate, which means they're able to communicate back and forth with each other and all that good stuff that goes along with it. And right now we're squared away. Everything looks pretty good. Now if I go and I do a failover exec standby, I can type in the command of show failover, and what this command is essentially doing is it's sending a command from the primary firewall to the secondary, the standby failover, the ASA that's in the standby mode. And what he is doing is he is running using that interconnection, that gig0/1 interface. He's actually sending these commands back and forth over that link to say, okay, what do you know about? What's going on? And if I do come back here, I do a show interface IP brief, you'll see that the outside interface is gig0/0 doesn't have an IP address on it. But if I do a show interface IP brief here, there is an interface IP on the active firewall. Now, what's going to end up happening is if something does happen on ASA3, the primary ASA3, so this is the original ASA3, something happens, then after a period of time, you're going to see ASA4, which is now the standby guy, he's going to kick in and start forwarding traffic. Now, I can actually come in here and say, on this guy, I can say failover is active, which means that ASA4, so the secondary standby, will become the new active mate. So now it's switching to standby. So we see that it's now, instead of primary active, it's now primary standby. We look on ASA4, we can see that I am now the secondary active instead of the secondary standby. Now if I go back to test 15, notice my connection was killed. If I go back to this switch here, or this firewall, and do a show con long, you're not going to see that entry in the firewall. If I do it over here, you will see it here. Now the reason why you'll see it here and not see it on the other side is because it hasn't timed out of the connection table yet. So that's basically how this comes into play. Now, with all of that said, pretty much everything that I've done is pretty straightforward. Now I can go back to test 15, and I can hit the up arrow and retelnet, and you'll see that things are a little sluggish. It's not exactly the best experience. Show interface IP interface brief. It's pretty slow. That's expected, especially in a failover pair. So no big deal. So I can go back to ASA3 and I can type in failover is active. Hit the enter key. Now I'm now primary active again. ASA4 is now secondary standby. I go back to ASA3. I go back to test 15. Hit the test 15. I've been kicked from my connection again. If I hit the up arrow and tell it to him again, it'll take it a second for it to swing over. But the benefit here is because of the way that I've done the config back and forth, you see it being able to fail back and forth. So let's see if test 15 pulled it up yet. Okay, there's Control-Shift-6X. So what I'm going to do now is we're going to go to the next step of configuring the stateful high availability. Now, stateful high availability isn't that much of a stretch. It's just a matter of knowing what to type in. And it's only 2 commands on ASA3. In global config, we have to type in show interface IP brief. We have to type in interface gig0/3 no shut on both sides. Show interface IP brief. Interface gig0/3 no shut. Now it says it's basically saying, you know what, it's not a good idea for you to do this. So the configurations are no longer synchronized and stuff like that. So it's better to do all your commands on this side and show interface IP brief. We're squared away. If I was to type in shutdown now and go back over to ASA4, that port should now be shut down. If I go back to ASA3 and type in no shut and go back to ASA4 and hit the up arrow, that port should now be up, because ASA3 is the one that's doing all the back and forth. So that's why we have that link between the two. That's how all the control plane itself, configuration steps, are synchronized between the firewalls. So what I'm going to do is I'm going to come in here and exit out of here, and I'm going to type in failover link, give it a name of something. I'm going to call it SFFO for stateful failover. And then I'm going to define the interface. So in this case here, it's going to be gig0/3. And I'm going to type in failover link or interface IP SFFO. And I'm going to use another, the second /30 out of the 255 range. So I'm going to type in 192.168.255.5/30 with a standby of 192.168.255.6. So now that we have it in place and everything is good to go, I should now be able to go to ASA4, and you'll notice that it popped up and gig0/3 is set up now, and we have an IP address applied there. I go to ASA3. Now what's going to end up happening, this is a little bit different than our last example. If we do a show failover and hit the enter key, now we're going to have all of this information here. We're going to have a failover link going back and forth. So ASA3 and ASA4, they're going to be basically synchronizing their information. So if I go back to test 15, I hit the up arrow and I do a telnet to, R2, and I type in Cisco and I log in. I could do, theoretically, I should be able to type in any command that's going to keep active data going back and forth. So let's just do a, I'm telnetted into R2. Now if I was to do a show IP, and you can see it's a little sluggish. So my guess is R2 is probably spitting errors going, oh my god, high utilization on the interface. That's what I was expecting it to show. So what matters is this is an active telnet session, right? So I can do this. Now what I should be able to do, I'd really like it to not be hung up, but it is. R2 is like spazzing right now. Not sure why it's doing that, but it is. So what I'm going to do is on ASA3, I'm going to come in here and I'm going to type in the failover exec standby, and I'm going to type in the command failover active, which is going to trigger the standby to become the active, which it did. So now if I go over to this guy and I do a show failover, we should see data coming across. So we see TCP connection. This is what I want you to focus on right here. If I go back to test 15 and I hit the up arrow, it's, for some reason, it's hung up. And I don't know why. It's an R2 problem, 100%. But as soon as this clears, which is kind of hosing up my test here, what you'll end up seeing is your connection is synced between the firewalls, and it's it does work. Now I can come in here and probably do a really long ping and just type in repeat something really, really high, like 100,000. We'll just do 10,000, right? So now it's pinging, well, sort of pinging, and it's going out and it's doing its thing. Now I should be able to go to ASA3 and hit the up arrow and show failover, and we should see data going back and forth, which means that there are going to be data being sent back and forth. I don't know if this applies to specifically to ICMP as well. I know TCP connections are affected. I'll go ahead and just Control-Shift-6 on that. And let's try to telnet to R2 again. R2 is just not having it today. R2 is like, I am done. Let's see. Show run, section line. I was testing this out earlier, and it seemed to do the operate very similarly. So it does have telnet input. Still trying to connect to it. Oh, there. Yeah, it's fine. Okay, so it finally timed out. So if I go back to ASA 3, so the test that I wanted to do was to have an active connection to R2, and for whatever reason, it's just not having it right now. Okay, there it goes. It's like it. So I just want to hit the enter key a couple times, just like that. So R2, okay, so that's squared away now. So I should be able to come back in here and do a show failover. There's data going back and forth. We see the TCP connection climbing. If we do a failover active to send this guy back as the active failover, he's squared away now. Or no, I'm sorry. He's been active for a minute now. Maybe that's why it wasn't working. Now it's not working. Well, you see the point that I'm trying to get across. It's supposed to, as soon as I stop clicking on it all the time, it's supposed to allow the communication to go back and forth. And if we do failover active and we do the show failover, the data keeps going back and forth. Test 15. I don't know why it's hung up. Control Shift 6X. So I know there's communication. R2 is just probably pegged. But now if we go back to, and the reason why I wanted to do an active TCP session is because it's end-to-end communication. But for whatever reason, it's hung up and not wanting to participate. But the simple matter is, we do a show con long. We can see the session going back and forth. We know that it's working, so then we can go ahead and type in failover active. He becomes the active guy again. Do a show connection long, and the sessions are maintained. If I do a show failover, the connections are incrementing. Not that necessarily means a whole lot at this point, but that's basically what's actually happening. So it is working to a degree, but at this point in time, we've configured failover, we've configured stateful failover, and that's pretty much what the most you can do. There are a few additional things you can tune it to make it, the amount of how many interfaces have to fail before failover actually takes effect. What the timers look like. There's some tuning things you can do. I might cover that later on when I come back to it. But right now I just wanted to cover some basic failover. And that's pretty much where it sits. So that's pretty much it, guys. Thanks so much for stopping by, and we'll catch you guys in the next video.